We'll continue in calculating maxima minima. Now it's term for 3D. Okay, so we have seen 2D. 2D calculating the maxima minima or the extreme point, critical point. So critical point is that if I have a kind of rate of collection as algebraic equation, rate of collection as algebraic equation, then if I calculate the integration, then I get the net collection. That is the area, that is the addition, that is the summation. So this is what that we saw. So net of that rate of collection is there, and if I integrate to get it the net collection. If I have net collection, then if I differentiate means divide by the independent component, if I have net collection and if I differentiate, then I get the rate of collection. Rate of collection to get, I differentiate to get the collection from the rate of collection. To get the net collection from the rate of collection, we integrate. This is what we saw. Now, if I have a collection graph, if I have if I have a collection graph, and in the collection graph, if I differentiate to get the rate of collection, then rate of collection, okay, so from collection, if I go ahead and calculate the rate of collection, then rate of collection, if it is going up, rate of collection, if rate of collection is going up, means that the collection is coming, means per unit charge, per unit, if I say rate of collection per hour, then per hour, if collection is positive coming, then per hour with rate of change, 1 unit hour per unit hour, means in 1 hour, what is the collection? So if this is x-axis is the time and y-axis is the collection. If this is time and this is kind of collection, then per hour if I take, then how much is the collection? Collection per hour. That is the differentiation. So if there is a positive collection per hour, then graph will be like this. If there is a negative collection per hour collection is negative. Means things are not coming, things are going away. In that case, the graph will be down. If per unit time there is no change in collection, then graph will be flat. That is called extreme point. If graph is like this and then it is going like this, then at this point, okay, it is flat, and at that flat point, the rate of collection is 0. Okay, so when rate of collection is 0, it is neither increasing nor decreasing, 0. That is considered as extreme point. Extreme points means at that point it 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 make a sharp change. So either it can be maximum or it can be, it goes like this and comes like this. It can be minimum. This is what we saw in 2D. Now, the biggest part that is here is that, so the kind of the rate of change, that is dy by dt or dy by dx, is 0. If it is 0, then either it is minimum or it is maximum. Then how we can calculate that it is minimum or it is maximum? Then if I have a function, if I have a collection graph, not the rate of change of collection, if I have a collection graph, the point where I am suspecting that it is the extreme point, there before the point I have to take the collection, and after the point I have to see the kind of collection. So if I have the collection graph, if I have the collection graph, then probably kind of I can know that it is maximum or it is minimum. Okay, so if collection is, if the vertical is more, if vertical is kind of, okay, so if I have a graph like this, if I have a graph like this, and this point at t equal to this point, I am considering there is extreme point. So what at this point, what is the vertical, and before this what is the vertical, and after this what is the vertical. If before and after vertical is higher than this point, then this is minimum. Now if I go for like this, then I calculate the vertical where I am seeing the rate of change is 0. Prior to this and after this I check. If it is less than that, then it is maximum. But these are kids story. Means if you want everything automated machine to do everything, then the better way to do this is to calculate the double differential. So if we go for a double differentiation, then if our double, so if I am calculating the differentiation, if I am calculating, if graph is like this, then prior to this the differentiation is negative, and then after this differentiation is positive. If I draw differentiation graph, then it comes negative, then goes to 0, and then positive. If this is the graph, then at position where it is changing, that position it is like this. So the d2y by dx square double differentiation is positive. If double differentiation is positive, means it is minimum. Whereas if it is maximum, if it is going like this, then dy by dx initially it is positive and dy by dx is negative. If I draw the graph, it is positive, then coming to 0, and then negative. Okay, so when it is passing the origin or it is intercepting the x-axis, it is coming like this. So d2y by dx square is negative. So if d2y by dx square is positive, then it is minimum. If d2y by dx square is negative, then it is maximum. So this is neatly we saw in 2D. Now we will move to 3D. So 3D plane, I have now x-axis is replaced by xy plane. If it is xy plane, if this is replaced by xy plane, each point on the xy plane contributes one vertical point. So now the vertical was y, now vertical is z. Now horizontal was a line, now horizontal is a xy plane. So in xy plane, I have set a point that is x comma y. If it is x comma y, then for each x comma y, what is z value? Okay, so z equal to fxy, z equal to fxy, function over xy. Now, if I say this, then it can be any volume. So it can be any volume. Let's try if I have really some volume. Okay, I re I really have some volume. If this is the volume, then can you see that it is completely 3D? Means this is XY plane. Okay, so this is XY plane. On top of which this volume is kind of sitting. Okay, but how it is drawn? If this is xy plane, against each xy I have a vertical. So vertical point, if I connect all the vertical point to generate a surface, then it would become like this. Because now if it is a, if here if we see the underneath this, there is, it is taking this much point. Against this point there are heights. Okay, at each height point, if I connect, then it becomes like this. Okay, now in two-dimensional we had a graph like parabola. Here it is parabola in xz plane. If this is x-axis and this is y-axis, this is z-axis. So in xz plane, this is parabola. In yz plane, this is parabola. Now if I make round, then it becomes paraboloid. Okay, this is the story of parabola. Now what is dy by dx? Differentiation. Differentiation is change in vertical. How many vertical is changing, how many unit in vertical it is changing when there is one unit change along the horizontal. So horizontal, if I change one unit, then how much vertical it changes? If I take any point x, then from x, if I take delta x as variation in x or around x delta x whatever, then how much delta y would vary? Dy by dx. Where in 3D, if I take variation delta x along x-axis, variation delta y along y-axis, so there is a delta a variation at point x comma y or around point x comma y. X comma y is a not 2D point, not 1D point. So at x comma y point, if I take a delta a, then in that delta a, if there is a delta x variation, delta y variation, then how much is the delta z variation against delta x and delta y? If that is the case, then delta z, okay, then delta z by dA, delta z by dA. So that is the differentiation. But dA is nothing but delta x, delta y. Now, how much if now I have two planes. One is ZA plane, ZX plane, XZ plane, and one is YZ plane, and one is XY plane. Okay. So now can I see the variation of Z with respect to one unit change along X axis? Variation of z along one unit change along y-axis. So if this is paraboloid and if I see the xz plane, this is xz plane and this is yz plane. So along xz plane, if I vary delta x, then how much z would vary? That is called partial difference. So dz by dx. Along yz plane, if I change y, delta y, then how much z would change? That is dz by dy. If I make delta A change, then how much z would vary? That is dz by dA. Okay. Now, if I have an equation fxy, if fxy is the equation, this is function over x and y. If this is function over x y, suppose the function is x square plus y square. This is typical parabola. Can you see? X is varying x square, y is varying y square. So in parabola, y equal to x square. Now z equal to x square plus y square. So if I want x square plus y square, means along the x-axis it is varying like this. Along the y-axis it is varying like this, x square plus y square. If I rotate this, then it will become a paraboloid. It will become like this. Can you see? Or this is paraboloid. This is better paraboloid. This is really paraboloid. Okay, where this is at origin and it is going like this and it is going like this. So this is paraboloid. Now along the x-axis it is varying like this and along y-axis same way it is varying, x square plus y. Now to find the rate of change in z with respect to x in xz plane, if I take only xz plane, if I cut the sphere in xz plane, then along the xz plane, if I take dz by dx, then it will come as 2x. If I take dz by dy, then it will come as 2y. So 2x, 2x along is the kind of differentiation in xz plane. Now 2y is the differentiation in yz plane. Now if xz plane, now in 2D, if we wanted the extreme point, then I had to set it to 0. Differentiation should be 0. Means rate of change, there should not be any rate of change. But if you see closely, from here onwards, it is going on. So if vary delta x, then delta z is varying. It's this direction also. Only at this point, this guy in xz plane is coming like this, and then it is changing its direction. Where is it changing the direction? At this point, then there is no, it is flat. At this point, there is no variation. So dz by dx is 2x. Now to find the dz by dx along x-axis, if z is not varying, then 2x equal to 0. Same thing I have to say. So x equal to 0. Same way to y equal to 0. Then y equal to 0. X equal to 0, y equal to 0. If that is the case, then when x and y are 0, 0 at origin here. So in this plane, if this is the xy plane and this is the origin, can you see the dot? If this is the origin, on top of the origin, then that is the scenario. So here at this point, then there is no dz by dx, and there is no dz by dy. If that is the case, then there is no dz by dx, and that is the case when there is no dz by dy, then there it is kind of it is tangential. It is extreme point, critical point. Now, if that is the case, then x is 0, y is 0. So x equal to 0 and y equal to 0. This is critical point. Now, how I can find that it is maxima or minima? So if that is the case, then I have to see the contour. You remember if it was 2D, then I was taking the equation and there I was seeing the left side and right. So here I can see the left side and right side in xz plane. I can see the left side and right side in yz plane. Okay, more or less, then we are making a z-axis cross section, that is called contour. So if I take all together, if I say xz plane and yz plane all together, then we are taking the kind of in vertical axis we are making cross section. If we are making cross section, then it is we are making cross section along the in y along parallel to the yx plane. So there, or like if I say it is x square plus y square, then if x is more than 0, then it is if x comma y at x comma y equal to 0 comma 0, then x square plus y square means it is 0. Then if x is more, then x is certainly more than 0. If x is less, then again it is more than 0. If y is more than 0, it is more than 0. If y is less than 0, then it is less than 0. It is more than 0 again, because y is square. So x square plus y square is minimum at origin. Or I can draw the contours at various x comma y. If all the contours, the first contour I am drawing where x equal to 0.5 and y equal to 0.5. Next contour I am drawing, contour means the vertical cross section. If I am drawing the contour when x equal to 1, y equal to 1, x equal to 2, y equal to 2, and in x direction and y direction, both direction, if I am seeing the contour is growing, okay, then certainly it is the minimum. I believe it's all right. If I am taking equation was x square plus y square minus and in bracket x square plus y square. So if this is paraboloid, then paraboloid is tilted. Origin went up. If that is the case, then again x equal to 0 and y equal to 0. 2x and 2y equal to 0. Then x equal to 0, y equal to 0. This is extreme point. If this is extreme point, then we have to calculate the contour. So contour, if you see, when x is 1 and y is 1, then it is minus 2. If x is 2, y is 2, then 4 plus 4, 8 minus 8. So at origin, the contour is 0. After that, always it is minus. So it is going down. So it is maximum. So how to calculate it is maximum or minimum? Then I have to draw contour around the critical point, and then we have to find the from critical point, at critical point what is the height, and then after that around x-axis and y-axis what is the height. If height is keep on growing in the contour, means you hit the extreme point as minimum. If it is keep on decreasing, then you hit the critical point as maximum. Okay, so that is the kind of mathematics in 3D. Okay, now suppose the take example of a cone. Okay, now it is 3D, so certainly I can draw a cone. Okay, so I really have a cone. Okay, so this is pure cone. Can you see that? This is a cone. This is a cone. If this is a cone, then the equation of this cone is x square plus y square square root. So when x square plus y square root, this is the typical formula of a circle. So it is actually a circle. If we see the xy plane, then circle is radius is 0. then circle is keep on growing, and the way we are growing in xy plane, since x square plus y square square root, then vertical is also growing. So it is like this, and it is forming a cone. If it is a cone, then now I have to find the critical point, if critical point exists. So a square root of x square plus y square. Now if I differentiate it, then it will become x square plus y square to the power 1 by 2, means 1 by 2 into x square plus y square power minus 1 by 2 and 2x. So dz by dx, then it will come as x by square root of x square plus y square. Similarly, y by a square root of x square plus y square. Now, if we see that if I equate it to 0, if I equate it to 0, then when it will become 0? Xy square root of x square plus y square. Never. If I keep x as 0, okay, if I keep x as 0 and y as 0, then it will become undefined. Okay, if I keep x as 0 and y as 0, okay, then it would become undefined. If I keep again in y also, so at point 0 comma 0, this looks like extreme where it satisfies the, it should become 0. So it looks like extreme when x comma y equal to 0 comma 0, but at that point it is undefined, 0 by 0. Okay, 0 by 0. So the cone, when we see the extreme point, if cone is kept on the xy plane, then at this point, this is not paraboloid. This is a sharp point where radius is 0, not 1, 0. So it coming like this, and then suddenly it finds a point which is not there or something like this, then it is going like this. So the dz by dx is negative and coming to undefined and then positive. Dz by dy from this side, from my side, if I take, then it is negative, coming to undefined, then going as positive. So if I have dz by, if I have dz by dx, okay, if I equate dz by dx to 0, and then we see that x comma y, okay, so dz by dx is 0, and then we see that it is a kind of, we find x comma y, and at that x comma y it is not 0, it is something like undefined. So now we have a case where kind of if we have undefined case. One case is that we have a kind of the derivative. Okay, when we calculate the derivative and we set at some point the derivative is 0. At some point the derivative is 0. That point is maxima or minima. But when kind of when we have a point where it is undefined, that is also a critical point. So not only 0, when it is undefined, then also it is a critical point. There can be other case also. Other case like x square minus y square, x square minus y square. So in x direction, it is x square, then in x direction it is going like this. Can you see x square, parabola? So xz plane would go like this, whereas yz plane would go like this, minus y square. Opposite parabola. One is x square, one is minus y square. So it would go like this along the x-axis, whereas along the y-axis it will be tilted or opposite way of parabola. How it will be like this? You can imagine now. It is like this, and then it will come like this. So it is like this, and then so it's like a horse. It is like this exactly. So in along x-axis it is going up, and along y-axis it is going down. X square minus y square. So if I do the differentiation, it will come as 0. X square 2x and minus 2y. So when it is 0 means x equal to 0 and y equal to 0. So when x and y is 0, at that point, same as cone, when we try to find 0, then equal to 0. So at that point, we find that x comma y is 0, and 0. So at the origin, it is 0, but it is something that is undefined. Okay, the differentiation at x equal to 0 and y equal to 0 is undefined. Here, x equal to 0 and y equal to 0 is defined. Dy by dx is defined. There dy by dx is x y root x square plus y square. If I take x and y both 0, then it is undefined. Whereas here, it is x equal to 0 and y equal to dz by dx is 2x and dz by dy is 2y. The equation of the function is x square minus y square. 2x equal to 0 minus 2y equal to 0. So x equal to 0 and y equal to 0. So if x and y are 0, at that point derivative is 0. So it is good case, but it is neither maxima. Along x-axis it is minima, along y-axis it is maxima. So four case we are seeing. Either it can be both direction, it can be minima, like we took example of x square plus y square. If I take x square plus y square paraboloid, okay, that is the paraboloid. If this is paraboloid, then in xz plane it is minima and yz plane it is minima. If I take then when x and y is 0, at this point it is hitting the sharp point. This point, the dy by dx is not known. Okay, x equal to 0 and y equal to 0, their dy by dx is undefined. That is also an extreme point. Or if I take a horse saddle where along the x-axis it is going like this and along y-axis it is going like this, then it is making a peculiar structure. There when x and y are 0, 0, then in along x that z plane it is minimum and in yz plane at that point it is maximum. So it is neither minimum nor maximum. So if I differentiate and then try to see either differentiation as 0 or differentiation as undefined at particular point, then that point is critical or extreme point. That is 2D plane. So if it is a minimum, then in both xz plane and yz plane, both it will be minimum. If it is maximum, then in xz plane and yz plane, both it will be maximum. It is undefined means either both will be undefined or one of them will be undefined. Or it is a saddle point where one it is minimum and other it is maximum. So all that we have kind of seen. So this is kind of maxima and minima in the kind of 3D. Now consider a case where if I differentiate dz by dx equal to x, dz by dx equal to x minus y, dz by dy equal to y minus x square. I'm sorry, dz by dx is x minus y equal to 0, x minus y, and dz by dy is y square minus x. That comes when I differentiate. So first case x equal to y, that comes because x minus y I have to set it to 0, and here y minus x y square minus x I have to set it to 0 to find the extreme point. So one is x equal to y and another is that x equal to y square. Suppose that is the case, then what would be the formula of the graph? If x minus y is the dz by dx and x minus y, if x minus y is dz by dx and x minus y square, x minus y or y square minus x is dz by dy, x minus y is dz by dx and y square minus x is dz by dy. So what would be the equation of the graph? That is the question. If x minus y is dz by dx, then I have to integrate this to find the graph. So that looks like x square minus yx, x square minus yx. If I do dz by dx, then it will come as some constant 2x. So x square by 2 minus yx. So it will come as x minus y. So x square leave the constant x square minus yx plus any function of y. So y will go. So the function of x minus y, if it is dz by dx, then function is x square minus yx plus function any function on y. Now if dz by dy is y square minus x square, then it is y to the power 3 minus xy. There it was x square minus xy. Here y to the power 3 minus xy plus any function of x. So the dz by dy, x would go out. Now if we combine these two, x square minus xy, y to the power q minus xy, and first there was a function on y only, and here there is a function on x only. So one function on y is yq, their function on x is x square. If I combine these two and fill the coefficients, then it will come as 8yq plus 12x square minus 24xy. If I have an equation like 8yq minus 8yq plus 12 2 plus 12 x square minus 24xy, then dz by dx would be x minus y. Okay, and dz by dy would be y square minus x. So first is x equal to y and second is x equal to y square. It would satisfy only when xy is 0 0 or xy is 1 and 1. Now we have, in this peculiar case, we have two extremes: origin, that is x comma y, 0 comma 0 and 1 comma 1. How we find that it is minimum or maximum? Now we will draw the gradient. We will draw the kind of contour, and we see that x comma, when xy is 0 0, then what is the situation of the contour around the 0 0? In xy 1 and 1, what is the situation around 1 and 1? If it is same around, all around it is same, okay, it is like v x square minus y square. Okay, one side it is x square, other side it is minus y square. If I draw the contour, then one side the contour will go up and other side contour would go down. So if I draw a circular contour, then one side it will keep going negative, one side x-axis will keep going positive. Then we can say it is neither maximum nor minimum. Here, if I draw at origin, so origin means x, y, 0. So y to the power 3 x square xy all will become 0. Now if I go in negative side, minus 1 and minus 1, so 8y3 will result in minus 8. 12x square will result in 12. So 12 minus 8 will result in 4. Whereas minus 24xy, so that would result in 20. That would result in minus 20. So net is minus. Okay. So if I would say I would go along the x-axis only. So suppose that it is minus 1 and 0. So now I am trying to find the contour at origin, that is 0 comma 0. I have the equation of the line is 8y plus 12x square minus 24xy. If I differentiate dz by dx and dz by dy, then I get x minus y and y square minus x. If that is the case, then x equal to y and x equal to y square. This is only possible when x comma y is 0 comma 0 and x comma y in other side is 1 comma 1. Now if it is 0 0, then I'll take along x-axis and y. If I take along x-axis, then I'll take a point that is minus 1 and 0. So if I take minus 1 and 0, then it will result in 12. If I take 1 and 0, it will result in 12. So around the 0 0 x-axis side, the contour is positive. Now go in y-axis. So there also I'll try minus 1, 1, 0, minus 1. 0 minus 1, then it will result in minus 8. 8yq is minus 8. Minus 8. And then 0, 1, then it is plus 8. 0, 1, minus 8 and plus 8. Means along x-axis it is always positive, along y-axis one side is negative. So around the origin, the contour is not same sign. So it is neither negative, this is neither maximum nor minimum. This is what we can say. Now 1 comma 1, there also we have extreme point. So if it is 1 comma 1, then along x axis I can take as 2 1, minus 2 1 and 2 1, and then again that side 1 2 and 1 minus 2. You can calculate and see that it is maxima or minima. If around the contour everywhere it is not of the same sign and then it is not incrementing or decrementing continuously, then it is neither maxima nor minima. So we saw a case where it is undefined. We saw a case where x square plus y square, where it is both side it is minimum, both side is minimum, or minus x square plus y square, both side it is maximum, or x square minus y square, where the contour are not same or around. So these are the ways. So drawing the contour, we can find now it is maxima or minima. There, now can you remember in 2D we were doing double differentiation. If we do double differentiation and it comes positive, that is minima. If we do double differentiation, it comes positive, then comes negative, then that is maxima. Can we do something double differentiation in 3D also? So that quickly I can find it is maxima, minima, neither maxima nor minima, or undefined. Okay, if that is the case, then what we have to do? Okay, now can you see one thing, that there is we draw, if there is a sine wave, right? If there is a sine wave, if there is a sine wave, if there is a if there is a sine wave, then sine wave keeps repeating. So if I take a region that is a closed region. Closed region means there is a region and there is a boundary. Okay, there is a boundary part. If there is a closed region, in closed region, if I can have only one maxima and one minima. But as region is growing, so in a kind of open region, then there is no local minima and local maxima. There is no, means there is kind, if the region is small, then I can have one local minima and one local maxima. But there is no boundary, then there is no global maxima and global minima, because there are many maxima and many minima. So sine wave and cos wave, there are multiple maxima and multiple minima. But if we take the case of parabola, there is only one extreme point, either minima or maxima. If there is a paraboloid, then there is only one minima or maxima. If I have a parabolic function, quickly I can find it is a maxima or it is minima. I can do double differentiation, or parabola is in shape of x square. If I say y equal to kx square, y equal to kx square, if k is positive, then it will lead to minima. 100% only one minima is there. So if equation of a line is y equal to kx square, when k is positive, then it is global minima. When k is negative, it is global maxima. So clear, right? So any function, if I have fx, if I somehow I mold it in equation of parabola, then finding the coefficient, quickly I can say it is maxima and minima. Okay, now because in when it is a 2D, then I did double differentiation and I quickly checked that it is maxima or minima. But in 3D, where independent variable are two, then double differentiation I calculate, then I may not know, because there are double differentiation in along x-axis has different shape, double differentiation along y-axis has different shape. Double differentiation if I do first along the x-axis and then along the y-axis, that is also a possible combination. Then there is a different move. That is the one problem. Double differentiation is of three types: fxx, fyy, and fxy. That is one scenario. Second scenario is it cannot be either maxima or minima. It can be case where it is maxima and minima both. So it is neither maxima nor minima, or it is a cone case where at that point the dy by dx is undefined. In that case, then we will say it can be maxima, it can be minima, or it can be nothing. It can neither be maxima nor minima, or it can be undefined. That we don't know. Like in cone case, we had a cone case. There, at this point dy 0, 0, it is undefined. If it is undefined, then it can be either minima, or it can be maxima, or it can be saddle point, or we don't know. So if we calculated the cone, so if it is a cone is square root of x square plus y square, then the undefined point dy by dx, dz by dx and dz by dy is the minimum. But if I take upside down cone, that is fxy equal to minus a square root x square plus y square, then cone is like this. If x square plus y square square root, then cone is like this. If minus square root x square plus y square, then cone is like this, upside down. Then it is global maxima. But if it is undefined, then we don't know it is either global maxima or it is global minima, or it can be saddle point, or that we don't know. Okay, so the case is it can be any four of them. Either it can be maxima, it can be minima, it can be neither maxima, minima, or if it is kind of becoming as undefined dy by dx, dz by dx and dz by dy, then it can be either minima, maxima, neither of them or undefined. So the 3D case is like we have fxx, fyy, fxy, three kind of differentiation and four kind of scenario. So this would be little different, but we will try to find out it is maxima or minima, okay, or whatever it is through mathematics, not through drawing the contour. That is the idea. So if it was 2D, then double differentiation, and quickly looking at the sign, we could find that it is maxima or minima. We will do similar here also. That looking at some sign, quickly I'll say it is maxima or minima as far as algebra and double differentiation is concerned. So that we will see. We have invented something, and we will see scenario in that is also invented by other people, but we invented. So what is the importance that I invented something when it is already invented? Probably the steps I follow, the way I would prove this, that is not available anywhere. That is the critical point. Means the way I'll prove the invention, my invention, that how I proceeded, that in algebraic way, I can say that it is maxima, minima, neither maxima, minima or saddle point, or it is a cone like of corner through the algebraic way. But this concept is already invented by someone that later I came to know. But the way I invented, that is something that is disclosure I can make. That is when I checked that, and that is not the way other people thought about it. So mine is very simple, very straightforward. Certainly, we will place disclosure. So we will move on.